By the mid-2000s, communication faced a strict physical constraint. You had the routing freedom of the internet, but your voice was trapped inside a heavy box sitting under a desk. The entire telecommunications industry was ripping out legacy circuit-switched phone networks and replacing them with systems that routed calls as digital packets over IP infrastructure. But voice over IP required users to make a harsh physical trade. To make a free digital call, you had to abandon the roaming comfort of your living room cordless phone, put on a headset, and sit anchored to a computer monitor. Hardware engineers tried to break this tether. Early handhelds, like Windows Pocket PCs, attempted to run VoIP clients, but relying on a 400 MHz processor to compute heavy digital voice compression without a dedicated microphone jack resulted in immediate battery drain and severe echoing. Separating the phone call from the PC chassis created a strategic battle over ecosystem control, establishing the rules for how organizations evaluate technology infrastructure today. To successfully bridge the gap between digital networks and physical hardware, the industry split into two opposing philosophies: closed proprietary ecosystems and open standards. Skype operated as the undisputed champion of the closed ecosystem. They controlled the software, the network routing, and the user interface. The alternative was SIP, the Session Initiation Protocol. It was a completely open framework designed specifically to let any manufacturer's hardware communicate with any network. If you are investing capital into physical infrastructure, you face an immediate dilemma. Do you select a system that works flawlessly right out of the box but locks you into a specific vendor? Or do you adopt an open standard that connects to everything but demands constant technical maintenance? Looking at this decision tree, we can follow these two paths to see exactly how this trade-off plays out in the real world. Software that removes the setup burden always extracts a toll in hardware flexibility. To measure that toll, we have to look closely at the hardware built to support it. Skype's primary technical advantage was its decentralized peer-to-peer architecture. This flowchart compares a centralized SIP server against Skype's decentralized model. Skype offloaded routing to supernodes, everyday computers with high-speed connections. This direct peer-to-peer connection automatically tunneled through firewalls, while open SIP connections failed and required manual IT configuration. To achieve this zero configuration environment, Skype engineered its software as an opaque black box. They deployed advanced binary packing and anti-debugging techniques to hide their protocols, actively preventing third-party hardware manufacturers from integrating natively with the network. This forced a secondary technical trade-off regarding codec efficiency. Skype utilized a proprietary codec called iLBC. It was highly resilient, providing clear audio even if the messy public internet dropped 10% of your data packets. OpenSIP systems relied on the G711 standard, which required far more network bandwidth and was highly vulnerable to audio clipping and jitter. But Skype's resilient audio carried a physical cost. The iLBC codec required intense localized CPU processing to compress and decompress the voice data, which rapidly drained the batteries on early mobile hardware. Skype's software engineering intentionally sacrificed native hardware interoperability to protect its market dominance. To get around this lockout, manufacturers created USB adapters like the Zonet Skybox S1 to bridge standard analog phones to the closed Skype network. This diagram breaks down the bridge. You plug the physical phone into the USB adapter, but you need a mandatory layer of middleware installed on the operating system. This software translator triggers actions inside the opaque Skype client. Users gained a clear benefit. You could pick up a standard cordless phone, walk 300 feet away from your desk, and seamlessly merge traditional landline calls with digital internet calls on a single device. But this setup contained a fatal architectural flaw. By relying on middleware, you turned the desktop PC into a localized server. The computer had to remain powered on 24 hours a day, tying the reliability of your telephone directly to the stability of a desktop operating system. Forcing the PC to act as a permanent, energy-draining physical bridge entirely negated the goal of true untethered telephony. Manufacturers eventually evolved their hardware into dedicated Wi-Fi handsets, embedding the Skype application directly into the firmware of devices from Belkin and Netgear. These handsets successfully severed the PC tether, They operated independently and boasted impressive metrics, like 36-hour standby times. Yet they encountered a severe networking constraint the moment they left the house: captive portals. Public hotspots in airports and cafes demand that users accept terms of service or pay via a splash screen. Because the Wi-Fi handsets lacked a built-in web browser, they could not authenticate the network connection. Conversely, open SIP hardware possessed the flexibility to be integrated directly into corporate Wi-Fi networks using enterprise-grade authentication protocols. The promise of a device that could travel anywhere was an illusion. Closed ecosystem hardware was ultimately trapped inside pre-configured home networks. We can translate this historical data into a practical evaluation matrix for any modern IT infrastructure investment. This chart maps ecosystem choice. The vertical axis measures ease of setup, the horizontal measures hardware flexibility. Proprietary platforms like Skype sit top left, frictionless setup but severe hardware limits. Open standards like SIP occupy bottom right, ultimate flexibility but a steep configuration curve. Corporate valuations heavily favor frictionless software. In 2005, eBay acquired Skype for $2.6 billion, based entirely on its massive, rapidly scaling user base. But despite the backing of major tech executives, closed systems failed to dominate corporate PBX infrastructure. Enterprises simply required too much multi-vendor hardware interoperability. Before committing capital, organizations must objectively decide which quadrant they belong in. You cannot have both frictionless automated setup and total hardware control. This leaves two distinct user profiles. First, the frictionless adopter. If rapid user adoption and network resilience are your top priorities, select the proprietary route. But you must accept that you will be permanently locked into their specific hardware partners. Second, the infrastructure controller. If your operations demand deep integration with multi-vendor hardware or advanced routing, you must adopt open standards and shoulder the heavy IT maintenance burden yourself. We can observe the final life cycle of these decisions today. Microsoft announced the total shutdown of Skype in 2025. This decision effectively dissolves the closed ecosystem and every piece of proprietary hardware tied to it. In technology, you either control the hardware integration via open standards, or the software ecosystem controls you.